Now, the entire Pre-Calculus 1 course, let's say 90% of the Pre-Calculus 1 course, is based on a few basic functions. More than 5, fewer than, can't show you 10, I got chalk in my hands, fewer than 10. Arguably, the two most important are these, but there's another one that's also extremely important that we learn a lot from. And then the others are actually equally important, or more or less as important. They're all important, but by understanding 3 of the 5 most basic functions, so the 3 super basic functions maybe, we begin to understand a lot about pre-calculus. And of course, we do a lot of algebra with these functions, but the first thing we want to do, because our algebra skills need to develop a little bit, first thing we need to do is understand the arithmetic and the graphs of these functions. Okay, so y equals x squared, your basic square function. Make a table, x values here, y values here. Let's not worry yet about the negative values. We'll fill those in shortly. But we've already just seen the values of 0 squared, 1/2 squared, 1 squared, and 2 squared. Okay, we've seen that 0 squared is 0. We've seen that 1/2 squared is 1/4. Okay, remember the picture there. If we've got 0 here and 1 here, take half of a half, and there it is. There's 1/4. 1 squared is, of course, 1, and 2 squared is 4. And of course, our picture there. We've got 0 and 1. Here's 2. Here's 2. Here's another 2. Here's 4. And we've seen these pictures, so I'm just kind of alluding to the pictures. Okay. And of course, we could do the calculation. I don't want to take up too much space here. And actually, I'm not going to do the calculation here because I want to leave myself room for the graph. I'll kind of take some notes down here about the calculations. I'll say 0 squared. 0 times 0, which is 0. 1/2 squared, 1/2 times 1/2, which is 1/4. 1 squared, hardly have to write that out, but there it is. 2 squared is 2 times 2, which is 4. Okay, so right there we have x and y coordinates of 4 points on a graph. Well, let's go ahead and start sketching a graph. Our x values here go from 0 to 2, but you see they're going to go from -2 to 2. So I'm going to sketch a graph here. My x-axis going from -2 to 2. And halfway between -2 and 2, wherever that is, let's say it's about here, that's going to be 0. Notice I just subdivided the interval from -2 to 2 into 2 pieces. And then I'm going to divide the interval from 0 to 2 in half. That's going to give me 1. And the interval from 0 to 1 in half to give me 1/2. I don't need to go any further because my numbers here are just 0, 1/2, 1, and 2. And right there they are. On the other side, I've got -2 up to 0. Well, I can subdivide that in half. I get -1. Subdivide the interval from -1 to 0 in half, and I get -1/2. And now I've got all the values I need to plot these points on a graph. Okay, well, I need y values from 0 to 4. Here's 0. Of course, the y-axis goes through x equals 0. It's very important to always remember that the y-axis is a set of points where x equals 0. The x coordinate of every point on the y-axis is 0. And that's really worth stopping and thinking about. The y-axis is exactly the set of all points whose x coordinates are 0. Okay, so let's go ahead and do this and put 4 up here someplace. Now, a lot of times we want to use equal scales on the x and y axes, but it's not necessary, especially if you're doing functions that have ridiculously big y values for much smaller x values. You just can't really do it. So we just get used to the idea that we're not using equal scales. And this distance here is clearly less than this distance here if my hands have the same size, which they pretty much do. Okay. So up here is 4. Now we want to scale this axis. And you note that we're going to need the numbers 4 and 1 and 1/4 and 0. Okay. Well, if we go from 0 to 4, we can't get 1 right away by subdividing the interval in half, but we're going to divide the interval from 0 to 4 in half to get 2. We're going to divide that in half to get 1. And we're going to divide that in half to get 1/2. And we're going to divide that in half to get 1/4. And I'm not going to label the 1/2 and 1/4 because the graph's going to get too busy in here. Okay. So we just understand there's 1/2 and there's 1/4. And if you followed what we've done so far, you really understand that. Okay. We can now plot the points. Okay, we've got the point 0, 0. So I'm going to use this orangish chalk here. 0, 0 would be here. And I assume everybody knows how to plot points. If some people don't, you know, I'll work with you a little bit in class. We'll make sure that we get that. Okay, then 1/2 goes with 1/4. So when x is 1/2, y is 1/4. I can make a couple of little dotted lines here, call these projection lines, to indicate that this point is directly across from y equals 1/4 and directly above x equals 1/2. Okay, then 1, 1. X is 1, y is 1. So here's a couple of projection lines that make sure that we've got this point pretty well. That projection line's going up a little bit, so it's not going to be perfect, but got it pretty well located. And then 2, 4. Okay, now 2. Try to make that projection line as vertical as possible. Make this one as horizontal as possible. And there I've got 4 points on my graph. Now, people will automatically want to connect these points. And we're going to, but not now. Okay, I'm not going to connect these points just yet. These are the points that correspond to these values. Now we've got points over here, and you probably know what they are. We'll get those in a minute. Okay, let's just stick with a pattern that we've already established in the first video. Okay, so basic exponential functions, y equals 2 to the x. Okay, well, most people coming into pre-calculus course don't understand how to do a negative exponent. It's simple, and I'm going to tell you in a minute. Well, not in a minute, but before too long. And most people don't understand that any number to the 0 power is 1, even though that's something that should be reinforced again and again. Since everybody does things by calculator, I suspect that that doesn't get reinforced because a calculator is always going to tell you that without anybody ever understanding it. Okay, I think that's bad, but I'm not going to let that persist in this class. I'm going to make sure we understand things. Okay, so 2 raised to the 0 power is 1. And right now you just have to take my word for it. Once we have dealt with exponents, and that's your first open math assignment, then we'll talk more clearly about why any number to 0 power has to be 1. Just for now, it's a rule, take my word for it, but there's a reason for the rule that we want to understand so we don't start forgetting the rule. Also remember the pattern that we saw before. Okay, according to this curve, 1 makes a lot more sense than 0. Okay. Okay, now, how do you do 2 to the 1/2? Well, you probably can go to a calculator and do that. But for these basic functions, we're not going to use calculators. We're going to use real understanding of the numbers and the rules. And the way you calculate 2 to the 1/2, and if anybody asks me, I can show you in 2 minutes how that could be calculated to as many decimal places as you might wish. But that's something you learn in the second semester of calculus, okay? But I can write down the formula for you. It's not hard to understand. But the problem is, it never ends. You never get an exact value. Okay, so for 2 reasons, and let me first write 2 to the 0 is 1, because I say so, because everybody says so. 2 to the 1/2. Can't be calculated exactly. So we don't use it. So I'm just going to say, omit this. Doesn't mean that 2 to the x doesn't have a value for x equals 1/2. It certainly does. We just don't know exactly what it is. We narrow it down as far as we wish. We'll never know exactly what it is. Okay, then 2 to the 1 equals 2, clearly. And 2 squared is 4. And no problem with those numbers, which means that we can begin to sketch this graph. Very similar to what we did here. Take the interval from -2 to 2, do some subdividing, just as we did before. And we don't even need 1/2, but we kind of and get in the pattern and we go ahead and put it on there. It could be very helpful because we could, if we get a good graph, we can estimate from the graph what the value of 2 to the 1/2 is. It's not going to be exact. We can't say that we've really got it, but we have a pretty good idea of what it is. Okay, and of course, we're going to need numbers that go up to 4. We don't seem to need 0, although it's going to turn out that we need numbers close to 0 when we do the negatives. But again, our graph's going to look something like this, and we're going to plot our points. Our points are pretty easy. 0, 1, 1, 2, and 2, 4. Okay, and we note that the slope here is less than the slope here. So that's a good start. Now let's go ahead and talk about how we would calculate 2 to the -2, 2 to the -1. And we're not going to calculate 2 to the -1/2 for the same reason we couldn't calculate 2 to the 1/2. We can't calculate it exactly. So we've only got 2 calculations to do. Okay, well, We have a rule of exponents, and you can't read everything I just wrote. Doesn't really matter, but we do want to keep this to where we can see it. Any number a raised to the negative b power is 1 divided by a to the b power. Okay. So keeping that in mind and making sure I don't go too far, okay, we can see that 2 to the negative 2 equals 1 over 2 squared, which is 1/4. And 2 to the negative 1 is just 1 over 2 to the 1, which is 1/2. So now we have y value of 1/4 and a y value of 1/2 when x is negative 2 and when x is equal to negative 1. So right here is our y value of 1/2. And down here is 1/4. I'm not going to try to label that. So if x is negative 2, y is 1/4. Well, right there is 1/4. So the y value has to be 1/4. And the x value is negative 2. That gives us a point here. And when x is negative 1, we get 1/2. X is negative 1. We get 1/2. And there's a nice smooth pattern to the curve that we're eventually going to get. Okay, well, for y equals x squared, let's go ahead and evaluate the results. If x is negative 2, we want to square it. So we're multiplying two negatives, we're going to get a positive. Negative 2 times negative 2 is plus 4. Now, all the way into the first month of the course, I see people wanting to write negative 4 here. Not because anybody is not smart enough to do it, but and doesn't know the rules, but because people are not attentive enough to follow the rules. You have to follow the rules, and you have to be aware of the rules, and you have to be focused on what you're doing rather than 10,000 other things in order to get this right and pretty much in order to succeed in this course. Okay, well, anyhow, there we have it. And then negative 1 squared is 1. And negative 1/2 squared is 1/4. That gives us points that you can easily verify. Go here, here, and here. So now we've got a picture of the graph of the basic squaring function and the basic exponential function. This graph has 7 points. This graph has 5 points. Basic squaring function has 7 points. The basic exponential function 5 points. Okay, I'm going to tell you what the domain and range of these functions are. Domain is the set of your x values. Here's your domain. Your range is a set of numbers, 0, 1/4, 1, and 4. Your range is a set of values that the function takes. Okay, you might be tempted to list 4 twice. Well, you could list it twice, but it would still be the same set. Okay, if 4 is listed here in the set, the function could take that value as many times as it wants. It doesn't change the fact that 4 is in the set, and it doesn't add anything to the set. So you just list the numbers, the y values. You list each y value once, no matter how many times the y value occurs. Okay. Over here, domain is a set of x values. It's not the same as the domain here because we've excluded 1/2 from the domain. Doesn't mean the exponential function doesn't have a value when x equals 1/2. We're going to estimate that in a minute. What it means is, though, that we can't calculate it. So we're not going to let it be in the domain of our basic function. Okay. The range is the set of y values. And you've got 5 of them. 1/4, 1/2, 1, 2, and 4. Okay. And that's it. You have to know this. Okay. You have to be able to construct it. You have to be able to explain it in every possible way. These 2 functions and one more that we're going to talk about. Okay, now, the basic squaring function. Okay, that's a basic squaring function. We're going to extend the basic squaring function. We're going to extend it by drawing a smooth curve, not a straight line, and a straight line. Now, the values of y equals x squared don't follow straight lines. It's never straight. Something just popped up. Oh, man. Norton antivirus. Okay, we'll do the extended function in a minute. I got to deal with this. Okay. I'm sorry, Norton antivirus has become a Norton virus, apparently. Pops up unwelcome and gets in the way on my screen. Okay. So we're going to extend the basic squaring function by drawing a smooth curve from this point down through this point and this one and back up here. I didn't quite get it right. It almost looks like the low point is there, but the low point is at the origin, obviously. Okay. And we call this extended basic squaring function. Okay, now I've got room here, pull this back here, kind of get the whole thing on the board, okay, on the screen. Okay, we can do the same thing here. Now we're going to call that the extended basic exponential function. I got rid of that exponential. It's a little wobbly, so I didn't get it written all that neatly, but you can understand what's being said. Okay. Now, the domain of the extended basic squaring function consists of all the numbers from -2 to 2. The range consists of all the numbers from 0 to 4. I don't have room to write all that up. But I will after I've done a couple of other things. So there's a domain and a range. And the domain and the range are not sets of points this time. They're intervals. Okay, we can even visualize the domain of in the range. But we're going to use those colors of 2 seconds. Okay. The domain could be thought of as all the points from here, all the x values from -2 to 2, because there's a y value for every one of these x values. In the range, all the numbers from 0 to 4. We'll do a little bit more with that, but I do want to mention domain and range, especially since one of the first things that's encountered in the open math assignments. Okay. And the basic exponential function similarly turns out to have exactly the same domain and range. Extended basic exponential function. The domain is the interval of the x-axis from -2 to 2, including -2 and 2. And the range is a set of y values from 0 to 4. Using the extended basic exponential function, I can estimate the value of 2 to the 1/2. Okay, so I'm going to bring this over here for a minute. This is an important point. If x equals 1/2, what's the y value of the point on the graph of which x is 1/2? Well, to find out y value, we come up to the graph. We come over here. So we have an x value and a y value. Okay, so estimate y equals 2 to the 1/2. Well, right there in the projection lines allow me to estimate this. Okay, well, 1 is here, 2 is here. If I subdivide that interval from 1 to 2 in half, I think that the half comes up just a little higher than this estimate. So it looks like y is approximately equal to 1.4. And that's pretty much an honest estimate from my graph. If I want to estimate y equals 2 to the negative 1/2. I can do that. And it looks like, pretty much looks like it's closer to 1/2 than it is to 1, but not all that much closer. So 1/2 is 0.5, 1 is 1, and looks like it's probably about 0.7. Okay. Let me make sure I've got room here. All right, that is 0.7. And it turns out that I did my graphs carefully enough that honest estimates pretty much nailed these to the nearest tenth, because those are the values. A little more extended value there would be 1.414. I think that's 0.707, something like that. I'm sure the 1.414. But of course, it doesn't stop at 1.414. It just keeps on going forever, which is why we can't calculate it. Okay, so there we have, now there's a terminology there. Basic exponential function consists of just 5 points with this domain in this range. The extended basic exponential function, well, I have room here. I can actually write out the domain and the range here. The domain is the interval -2, 2, including -2 and 2. So we have the closed brackets. Now that's a notation that everybody who's had prerequisites for this course ought to understand, but it's explained very well in case you lost track of it. Okay, explained very well in open math, and don't think you'll have any trouble with it. I'm having a little trouble, I can't see my screen. Okay, there we go. Okay. The range of the domain corresponds to this purple interval. Okay. Every point in this purple interval corresponds to a point on the curve. And it's exactly one y value for every one of these points. So one thing we can say is that, well, never mind, we're not going to say that now. Okay. Okay, the range well, you know, I messed up when I drew that range because I wasn't thinking. And put a dot right there, which I really shouldn't have done. I don't know what I'm going to do with all those smudges. Let's see. Okay, let me just finish repairing this. Y-axis does come down to here. And okay. Now the domain comes down to 1/4. There are no y values less than 1/4 on the extended basic exponential function. Now, the exponential function keeps going that way and keeps going this way. The complete exponential function does go all the way down to 0, except it doesn't ever hit 0. We don't need to worry about that right now. Okay, so the range goes from 1/4 up to 4. The range is then closed interval 1/4 to 4. Closed interval, meaning you have brackets instead of parentheses. The bracket means you including this point and including this point. If it was parentheses, it would just go up to this point and just up to this point, but would not include those points. Okay. There's your basic exponential function and a little bit about the values that actually do occur at -1/2 and 1/2. Okay. But again, those values are not exact, so we don't include them. Okay. I guess I won't say any more about that. Over here, for the basic squaring function, extended basic squaring function. What's its domain? Well, from -2 to 2. Again, your test is for every number between -2 and 2, there is a y value corresponding to that x value. So your extended basic squaring function domain is the interval from -2 to closed interval in the range the range, of course, is your set of y values. It's all the values from 0 to 4, including 0 and 4. So there's your basic squaring function. We can estimate values from the basic squaring function, although they're often pretty easy to calculate. And there are other things we could do. For example, one useful thing to see on this graph is the value of x next to y value 2 is what? Okay, well, we want y to equal 2. If y equals 2, we get a point on the graph whose x-coordinate is here. Looks like the x-coordinate that might be a little hard to read, but here's y equals 2, and this is the y equals 2 point on the graph. Right here. So here's the x value that makes y equal to 2. Looks like x is about 1.4. Okay, so what is that y value? It's about 1.4, or, of course, there's another y equals 2 point. Okay, And that would be negative 1.4. Much more I could say about those points, but I'm not going to do it now. If you want where y equals 3, okay, right there's about 3. I'll just project over it to the left. Okay. And I'll just say to get y equal 3, looks like that would correspond to the next value of about 1.7, negative 1.7. And I'll say or 1.7. I don't want to draw the projection. Well, I kind of can. Draw the projection line over here, come straight down here, and we get something like 1.7. Now, one of the things that we want to do ultimately is be able to freehand sketch these graphs accurately enough that we can make these estimates within plus or minus about 1/10. And if you're careful drawing the graph, and if you don't have absolutely terrible graphing skills, you can do that. Now, if you got terrible graphing skills, just as long as you make the effort and get reasonably close, it's going to be okay. But we want to be careful. We want to be able to draw these graphs carefully so we understand these functions carefully, and even more importantly, so we learn to pay attention to detail, which tends to be an inhibiting factor for people in a pre-calculus course. Okay, there's a third of the 5 most basic functions that I'm going to talk about. Once you understand these 3, pretty easy to extend that understanding to the remaining 2. And then we'll see other functions as we move on a little bit later in the course. Now, your basic reciprocal function is y equals 1 over x, the reciprocal of x. So if we make a table, we can easily calculate our y values. Okay, so that what's 1 over negative 2? Well, that's just the same as negative 1/2. And 1 over negative 1 is negative 1. So we get negative 1/2 here, negative 1 here. Then I'm going to skip 1/2 and move, or negative 1/2 for a moment and move to 1/2. So what's 1 over 1/2? So that means 1 divided by 1/2. And we can easily make a picture of 1 divided by 1/2. Here's an interval from 0 to 1. Right here is 1/2. It takes 2 of these to make 1. Okay? You need a 1/2 and a 1/2 to make 1. I'm not going to leave that on the board. It's in the way of the next thing I want to write, which is the value of 1 over 1/2. That's 2, because it takes 2 halves to make 1. That's what division means. So here we get 2. And then 1 over negative 1/2 equals negative 1/2, negative 2, sorry. Okay, because it's just like 1 over 1/2, except you got a negative in there, and that's going to make the whole thing negative. So this is negative 2. Then when x equals 1, 1 over 1 is clearly 1. And when x equals 2, well, 1 over 2 is clearly 1 over 2, which is 1/2. Now, what about 1 over 0? So this is a big deal. People mess this up all the time. Well, how many zeros does it take to make 1? Answer to that question is, this is the number of zeros It's how many zeros we need to make 1. How many zeros does it take to make 1? Well, you can't make 1 out of zeros. Okay. There's no answer. So 1 out of 0, 1 over 0 is sorry, it's a little hard to write down here at the bottom of the board. Hopefully you can read this. 1 over 0 is undefined. I don't have room to write out the whole thing, but I'll just abbreviate undefined. UNDEF. And you know what the rest of it is. So just kind of cross that out. It's not included. Well, now we have a table. We can easily mark the y-axis according to the numbers we have here and plot our points. So we're going to put 2 up here. And like the way I usually do it, I'll put 2 on this side. And then we come down an equal distance and we put negative 2 here. So that then we could have 1. And negative. And 1/2, not negative 1. We have negative 1 here. And negative 1/2 here. And we also have our 1/4 and negative 1/4. I won't label because things are getting kind of bumping against each other here. Okay. We can now plot our points. If x is negative 2, y is negative 1/2. I apologize for coughing. I just took a break and ate something. And apparently that caused some kind of irritation. Should go away shortly. Okay, well, I have negative 2, negative 1/2. It's going to be here. Negative 1, negative 1. Negative 1, negative 1. Here. Negative 1/2, negative 2. Here. Then 1/2, 2. 1, 1. And 2, 1/2. There is our basic reciprocal function. Now, broke my good piece of chalk. Domain is going to be the set -2, -1, -1/2, 1/2, 1, 2. 0 is excluded from the domain for the simple reason that you can't calculate this function if x equals 0. It's undefined, not because some rule says it's undefined, but because you can't make 1 out of zeros. And the range is the set turns out to be identical to the domain. Now, -2 in the domain doesn't correspond to -2 in the range. -2 in the domain corresponds to -1/2 in the range, as we can see here. But we list them in order, and we list everything in the range exactly once, okay? And the same is going to be true in the domain. Okay, there it is. Well, now we can do the extended basic reciprocal function. Now there's a little trick here. We can certainly follow the pattern of these points, and we can follow the pattern of these points. Okay, it's kind of symmetric, you know, it's a hyperbola, but I don't need to know that. I didn't draw that part real well, but there it is. Okay. Now, people will want to connect this point to this point. Okay. Well, it's not okay. You don't do that. Okay. Why don't you do that? Because to connect this point to this point, we've got to go through the y-axis. So if we were to connect this point to this point, let's just say we say, okay, I don't know what's going to go on here. But let's just say it's going to come down here, and it's going to come around here and come up here. Well, right away, you went through the y-axis, which means that you assigned a value for x equals 0. But we know when x equals 0, you can't define the function. So any number you get by messing around and trying to connect this point to this point, what takes you through the y-axis. And when you hit the y-axis, you've always said, well, now when x is 0, y is that value, okay? You've assigned a value to the function when x equals 0, and it doesn't have a value. So we don't go through the y-axis. So this part of the graph stays on this side of the y-axis. This part of the graph stays on this side. And it's going to turn out, and we can easily do this. We could, but we're doing enough for right now. Yeah, this graph, if we allow x values to go to 1/4 and 1/8 and so forth, the values of y will go to 4 and 8, 16 and so forth. They'll go up very steeply. It's going to stay on this side of the axis. That's going to give you what's called a vertical asymptote. You don't have to know that right now, but this is leading up to it. Also, when the x values get bigger and bigger, the fractions get smaller and smaller. If x is 20, instead of 1/2, you'd have 1/20. Okay, well, that's much closer to 0. So the y values get close to 0 as the x values go out this way. And they also get close to 0 as the x values go this way. They'd be negative on this side, but there you have it. So the extended basic function. Now let's talk about the domain and range. The domain runs from -2 to -1/2. We don't go beyond this point. Okay, so we start here and we end here. And then we pick up over here on this side. And we use this symbol to say, okay, the domain consists of all these points and as well as all the points from 1/2 to 2. Again, including 1/2 and 2 at the endpoints. That's the domain of this function. As we've defined it here. We define it as moving from this point to this point, and then from this point to this point. And the range well, looks like your y values could go from -2 to -1/2, and then from 1/2 to 2. Okay, well, let's illustrate this the way we did before. Your domain goes from here to here, because there are points on the graph corresponding to every x value between here and here. Right there they are. And then for every x value from here to here, you have points. Between -1/2 and 1/2, you don't have any points. Now, if you do what we call the complete reciprocal function, yeah, it extends all the way back to 0, but it doesn't include 0. Okay, so you fill in most of this gap except for the y-axis. Okay, similarly over here. Well, the range there's a point on the graph for every y value in this range here too. And for every y value here. So the range is the basic function, as we said. Okay, so there's your basic reciprocal function with its domain and range.